Hi guys, there's a question from section 3.1, problem number 29. So we have our function f of x equals x times e to the 4x. So as I'm sure you know the question, we have to do a couple of things. Number one, they want the critical values, if there is any, and then also if there is any local extreme values, which is local max or local mean. Okay, so right now, first of all, as you know, to find the critical values, we need a derivative. So this is going to be a product rule. Don't forget you have product of two functions. So the first function, I'm going to put the derivative inside the bracket so you can look at it later. You know, those are the derivatives inside the bracket. Derivative of e to the 4x, as I'm sure you remember, is the e to the 4x, and then times the derivative of 4x, which is 4. And that's, again, application of chain rule. And then plus the second function itself, which is e to the 4x, and then times the derivative of the first function. Of course, the first function is x, and of course, its derivative would be 1. So if you kind of clean this up algebraically, I'm going to put the 4 in front. So you have 4x times e to the 4x, and then also 1 times e to the 4x, which remain as e to the 4x. So now you can see there is a factor of e to the 4x from both terms. So we're going to factor e to the 4x. So from here, you're left with 4x. Here, of course, since you're taking the whole thing out, you just leave for the 1. So as you know, to find the critical values, we have to set the derivative equal to 0. So to find our critical values, we're going to set e to the 4x times 4x plus 1, which is our derivative, equal to 0. So, of course, you have product of two things 0, which means, of course, one has to be 0. So from here, you get either e to the 4x is 0, or your second factor, which is 4x plus 1, equals to 0. So if you remember from algebra, exponential function can never be 0. It's just going to get closer and closer, but it will never reach 0. Actually, not only can never be negative, it can also never be 0. So this one has no solution, so you don't get a critical value from there. But this one is a linear equation. So if you try to solve that, of course, as you move the 1 over, that becomes 4x equal to negative 1, and of course divide by 4. So you do get a critical value. I'm just going to put it right here, which is x equals to negative 1/4. Okay, so there is our critical value. Now to answer the second question, of course, to have a relative extrema or extreme value, which means maximum minimum, we have to look at the sign change as you cross over the critical value. Let me go ahead and take this. I do need the derivative here, so I'm just going to leave the derivative, because we're going to have to remember, check the sign of derivative. So for this was part A. So for part B, we're going to take the number line. We're going to split it at that critical value. And then we're going to observe the sign of the derivative. Okay, so to the negative, left of negative 1/4, of course, we can take negative 1. So I'm going to go ahead and, I guess, evaluate. So this was our derivative. So I'm just going to leave that there for a minute. So we're going to find f prime at negative 1. So negative 1 is our first test value, which is to the left of negative 1/4. So as you plug in here, negative 1, you get e to the 4 times negative 1, and then times 4 times negative 1 plus 1. So, of course, that's going to be e to the negative 4. 4 times negative 1 is negative 4 plus 1, which, of course, becomes a negative 3. Which, of course, is going to be the same thing as negative 3. You can take the negative e to the negative 4 downstairs, or leave it there. It doesn't matter. But as I'm sure you know, again, e to the 4 or e to anything can never be negative. So this is always positive. E to the 4 is positive. Of course, negative 3 is negative, which means this is less than 0, right? So you do have a negative on the first interval. So our derivative is negative there. And then for the second interval, we can take 0. 0 is to the right of negative 1/4. So if you evaluate, let me see if I can do that over here. If you evaluate f prime of 0, don't forget this was our f prime of x. It become e to the 4 times 0 times 4 times 0 plus 1. So, of course, e to the 0 is 1. Anything to 0 is 1. 4 times 0 is 0. 0 plus 1 is also 1. So 1 times 1 is 1, which means your actually, this was negative, sorry. On the left, negative 1 was here, so that answer was actually negative. I put positive, sorry. Now on the right, when we took 0 here, of course, we did get a positive answer, right? So we do have a relative, in this case, remember it goes from decreasing to increasing, so that gives us a relative minimum. Now to find it, of course, we do have to compute it. Don't forget, that's when you go to original function. So let me just, since we're done with the derivative, let me go ahead and find the exact point that will give us the local minimum. So we do have a relative minimum in this case because of, by the way, sometimes they call them local minimum, sometimes relative minimum. It's the same thing. So right now, all we need to know is, of course, we're going to say we have a relative minimum at, now we already know the x coordinate, of course, is negative 1/4, our critical value. Now to get the y value, which is going to be f of negative 1/4, so really it all comes down to one more computation, which is what is f of negative 1/4, okay? So you can actually, in this case, you can actually use a decimal notation because this number e is kind of not a whole number here. So we're going to go ahead and plug in. So I'm just going to find f of negative 1/4, so that way we have our exact point that gives us relative minimum. So f of negative 1/4. So back to original function, anywhere you have x, you put negative 1/4. So I'm going to go ahead and plug it in, and then let you check it with your calculator. So I'm just going to replace all the x's with negative 1/4, which, by the way, this becomes 4 times negative 1/4 is negative 1. So that'll just become negative 1/4 times e to the negative 1. So if you plug that into your calculator, I'm sure you'll end up with approximately, again, this is not exact, you can check that with your calculator, negative 0.092, I believe, is what I get on my calculator, okay? And that should be your value of your y value, okay? So now we have our exact relative minimum. I'm just going to go ahead and, I guess, put it here. So our final answer for our relative minimum would be, of course, the order per negative 1/4, which was the x coordinate. We find the y by plug it in, which is approximately negative 0.092. Okay, you can actually put this one also as negative 0.25 if you want to put both decimals, but negative 1/4 is already understood. So, and that should be your relative minimum for this problem. Okay, all right.